Here we go. So normally, the proper way that teachers normally teach it is they follow BODMAS, and then you go backwards, which is SAMDOM, right? The problem with that is that when you get the fractions, it gets scary. So what I normally tell students to do is, well, then if you don't like fractions, get rid of it to begin with, right? So in this scenario, if we have a look, this is your fraction. That's over 3, x over 3. But another operation, another way of looking at it is when you say x over 3, what are you actually doing? Are you adding, subtracting, multiplying, or dividing? Dividing. So if the dividing by 3, if divide 3 is the problem, then just undo it. Get rid of it. That's the first thing you're going to do. No matter what the problem is, even at your year 12 level where you get something like this, where you get like minus root x over root x plus 1 equals 2, for example, right? That looks scary, but even at my year 12 level and they don't know what to do there, I'm like, screw rid of the fraction. And it's the same technique that whatever I teach you now, you can also do with the year 12s. Same idea. What's the opposite of divide? Multiply. So if you got that divide 3, all you have to do is times 3. See this right here, this is saying x divide 3, and if you times 3, these two are going to cancel out, and I can prove it to you. It will just equal to x. Here's an example. If I took the number 5, and I said divide 2, actually, times 2, what's 5 times 2? 10. But then I say divide 2. What does that give you?
5.
Gives me 5. If I did 5 plus 2, and then I say take away 2, you get 5 again, because 5 plus 2 is 7, and 7 take away 2, you get 5 again. See, the pattern here is every time you do the opposite of each other, they're going to cancel out. It's almost as if you never had it to begin with. So even if I put the letter x, if I did something like this, x plus 1 minus a plus b plus c, yeah? Looks crazy. But if I said this, times by 3, and then I say the opposite of times 3 is? Divide 3. Watch what happens. It's still the same. Because we haven't done anything to it. We tripled it, and then you 1/3 it. It means that you haven't done anything to the function. It just cancels out. So the idea of this whole chapter is doing the opposites of each operation. And essentially, you're just removing whatever is currently there. So here, in this scenario, if you hate that divide 3, if that divide 3 is the problem, no matter what year level you're at, it's the same thing. Get rid of that divide by timesing. But remember how I showed you about the $5 equals $5 and then $3 equals $3? There was a problem. Here's the problem. You got to be careful when you times 3. Notice when I say times 3 on this side, this is what my year 11s and 12s do. They go, oh yeah, that cancels out. But they made a mistake already. What have they forgotten to do? Just like what we've forgotten to do with Ashwin's money when he had $3 with me. We both had the same amount. If you triple this side, you got to triple this side, right? Well, what am I missing? Yeah, this 2 here. See, there are 2 terms. It's like Ashwin with having a $1 coin and a $2 coin. You can't just triple the $1. You have to realize Ashwin has this entire thing as a total. That's why learning how to count the number terms was important. So you got 2 terms on the left, but on the right-hand side, I only have 1 term. That's why you only triple it once. But on this side, you actually have to triple twice. And that technique, as long as you don't make that mistake, then the whole thing will always work. So what I want you to write as part of your notes to remind yourself, when you get fractions and you want to get rid of it, how do you get rid of fractions? You just simply multiply. Multiply the denominator. Whatever the denominator is, who cares what it is? So for this year 12 problem, if you get this one and you see a year 12 doing it and you want to give them a tip, how do you get rid of this divide square root of x plus 1? What do you times it by?
By the square root of x. By the square root of x plus 1.
That's it. But remember, how many terms are there on the left-hand side? There's a plus sign here. That's 1 term. That's 2 terms. So if you times this by root x plus 1, you have to times this by root x plus 1, and you're going to times that by root x plus 1. Same concept. Okay, just looks more complicated. So, tip is, whatever I'm teaching you today, you can actually apply all the way up, all the way to any year 12 problem with a fraction. Yeah? So, let's do one example just to get you feeling somewhat easier to do these kind of questions. So 7C is all about fractions. So my tip is get rid of the fractions. Here, you got 5x divided by 2. So the problem is Had it been 5x, it would have been nice. But now it's, actually, let's check. Can we change that number to, what number should I change? I'll change it to 10. Change it to 10. Just so that we don't have to work with fractions here or answers being non-whole numbers. Let's keep it as 10. Now, the logic is, had it just been 5x equals 10, that would have been easier to work with. 5 times something equals 10, right? What would that number be if it was just 5x? 5 times what gives you 10? Yeah, 2, right? So that'll be nice. But the problem right now is you don't have 5x equals 10. You have 5x over 2 equals 10. That over 2 is a problem for a lot of students. So then I say, well, get rid of the fraction. This is divide by 2, so the opposite of divide 2 is? Times by 2. So if you times this side by 2, whatever you do to one side, you must do to the other. Times this side by 2. So let's work it out. 10 times 2 gives you? 20. Double of 10 gives you 20. And then on the left-hand side, you have to realize when you divide 2 and times 2, they're going to cancel out. That's the reality. It's just going to be 5x left over. And again, I can prove it by simply going here to my calculator and I'll show you 5x times 2 divide 2, still 5x. Or even if I did 5x divide 2 times 2, it's still the same thing because they're opposites of one another. You cancel them out. So here, times 2 divide 2 is going to cancel out. You're left with just the 5x. Now that's much easier. See, this is much easier to read. What's between the 5 and the x? What's the operation? Add, subtract, multiply, divide.
5 times x.
5 times x. This is a times. So if you want to get rid of times 5, because you're just trying to get x, you don't want that extra operation. You don't want that times 5. How do you get rid of times 5? The opposite of times?
Divide.
Divide. What am I dividing by?
20.
Divide by 5.
Divide by 5. Yeah, so divide by 5. But whatever you do to one side,
The other.
and that's when you divide 20 by 5 as well. So here we go. 5 divided by 5 is going to cancel out. You're left with x. So x now comes down. X is equal to 20 divided by 5 is 4. See that problem? So no matter which problem I'm going to give you in this exercise, even with a fraction, you still do the same thing. Get rid of that fraction and your life becomes easier. Because this step here is the easiest. This is where most students feel comfortable. When it's a whole number, 5x equals 20. It's when you have a fraction that scares you. So that's example 1. Let's do second example. Let's go on to B. So what do we do for B? B is the same thing, except I just made it look a bit more scary. Same thing again. You've got 3a plus 6 equals, divided by 2 equals to 9. What's the problem? This divide by 2. You don't like that fraction, get rid of it. Now be careful here. How many terms are there on the left-hand side?
1.
There's only 1, not 2. There are 2 in the numerator, yes, but as a term, it's 1 fraction. It's not 2 fractions. It's not 2 numbers. It's 1 whole fraction. So that means if you then do the opposite of divide 2, which is? Times 2, you only times it once, because there's only 1 term. So you double this side and you double that side only once. You don't have to double it twice. Elliot.
I'm gonna go the wrong way taking shape.
Oh, really?
I was only 5 stuff.
That's my yellow stuff. If those who want to have a look, this is what Elliot got.
Can I see?
What is this?
What Elliot got. I feel so sorry for him. He must have been like, what's going on?
Oh. So what is it?
What is it? It's like some sort of.
Money.
All right. Hopefully now you have. Wait, did you still get the right one? Did I give you the right one?
Yeah.
Oh, I just realized I picked up the wrong one as well again. All right, so we all got the right one. Okay, here we go. 3a plus 6 over 2. So same thing, you got to count. How many terms are there? There's only one big fraction, only one term. So to get rid of that divide 2, you just told me, times by 2. But you only times once because there's only one term. Whatever you do to one side, you do to the other. So here we go. Times 2 divide 2 is going to cancel out. What's left over? 3a plus 6. Okay, so write it down. You got 3a plus 6 left over. 9 times 2 gives you?
18.
18. Now this problem is much easier now. No more fractions and you do SAMDOB. This is what we did yesterday. Here we go. Let's do SAMDOB again. SAMDOB. You only use SAMDOB to undo problems. This SAMDOB is to give you the order of what to get rid of first. Get rid of any addition, subtraction. Then get rid of any multiplication, division second. And then any brackets and powers, you do that last. So, do I currently see any addition or subtraction?
Yes.
Yes, there's a plus 6. How do you get rid of plus 6?
-6.
Minus 6. So whatever you do to one side, you do to the other. So here we go. 6 take away 6 we know is 0, so it cancels out. What's left over? I have a 3a. 3a equals 2. 18 take away 6. 12. Now we're back to a very similar problem as we had before. What's in between the 3 and the a again? Times. So what I have now is a times 3. But I don't want the times 3. I just want a. So the opposite of times 3 is divide. So here we divide 3. But what do we do to one side? You do to the other. This is called balance the equation. 3 divided by 3 cancels out as we've known so far. A is left over. So a now comes down. A is equal to 12 divided by 3. 4. This is a methodical way of solving. So if I asked you triple of what number plus 6, then half that number, and it gives you 9, you don't have to do trial and error. The number is 4. Triple of 4 is 12. 12 plus 6 is 18. 18 divided by 2, or half of 18, is 9. So it makes sense. So this is avoiding the trial and error that most primary school students would do. We're now giving you a technique that as it gets more complicated, you can actually strategically solve. Okay? By doing SAMDOB. SAMDOB is the opposite of BODMAS. All right. Let's do the third example. Swap down. All right, be careful this one now. Second last example for today. So here we go. Third example. How many terms are there on the left-hand side? 2. You can see 2x on 3 separated by a plus or minus sign. So if there are 2 terms, that means if you happen to times, make sure to times every single term. Yeah? So here we go. You don't like fractions. Let's divide by 3. Copy this down, Mateo. Just make sure to copy these notes. That's a divide 3. What's the opposite of dividing 3? Multiply. So here we go. Times this by 3. But remember, whatever you do to one side, you do to the other. So we times 3 on both sides. But again, what's the mistake?
You have to multiply all of it.
Very good. So you have to times 3, but remember there are 2 terms here. You must times this 10 by 3 as well. If you don't, that's where the error comes in. And that's where the Ashwin money thing that I was trying to say. If he has $2 and $1, we have to make sure we triple every single amount. Yeah?
Couldn't you just get rid of the 10 first so it'd be easy?
You can, but that's where the students have to understand SAMDOB, and when they don't, this is my other way to do it. So usually I teach them to get rid of the fraction first because most students aren't good with fractions. But you're right. The general way that they normally teach you is to undo minus first and then get rid of the division afterwards. That's the proper way. I'm just teaching you another way that seems to help students when it comes to fractions. All right, team, so let's do this. We know that times 3 divided by 3 are opposites. They're going to cancel out. So I've got 2x left over. But then over here, negative 10 times 3. What's negative 10 times 3? Can I please have Liam? What's negative 10 times 3? Negative 30. Very good. And then over here, I've got 2 times 3. What's 2 times 3? Can I please have, yes, Ollie? 6. Now we are back to something more familiar with what we did in 7b. SAMDOB. Here we go. SAMDOB. Get rid of any subtraction addition first. Are there any subtraction addition? Yes, there is a minus 30 here. Opposite of minus 30? Plus 30. Very good, Elliot. Plus 30 on the left. Whatever you do to one side, you must do to the other. So plus 30 on both sides. Negative 30 plus 30 cancels out. I've left 2x, so 2x drops down. Next one, 6 plus 30 gives you 36. Notice the vertical layout. This is why it was important that you had to practice from the beginning of the year. 2x equals to 36, and then we go to the next one. Is there multiplication or division? Yes, there is. There's a times 2. Opposite of times 2? divide 2. Divide this left by 2. Whatever you do to one side, you do to the other. Divide this side by 2. Here we go. 2 divided by 2 cancels out.
Becomes 13.
X is equal to 36 divided by 2.
13.
No. 13. Double 13 is 26. I want 36 though.
Oh, yeah.
18. Beautiful.
I got mixed up.
All right. Now the last example for today. There's a trick to it. I see a lot of mistakes. Even yesterday's quiz, I did this as well. And there's a lot of students who made a mistake here. So let's go through the common mistake. Have a look at this one. Same thing again. The fraction is a problem, but you know what the hidden thing I did? I put a minus here. See, all the other problems was a positive in front of the x. Wherever the x is, usually it's positive. It's easier. When I put a negative, students screw up. And I'm going to show you again. Let's do it the correct way. Here we go. Get rid of this divide 3 because most students hate fractions. Times 3. But remember, how many terms are there? There are 2 terms here. So when you times it by 3, you must times them all by 3. 3 divide 3 cancels out. Yes, it does. Okay, so I'm going to cancel that out. So 3 divide 3 cancels out. Let's work it out. 3 times 2, 6. This one is left over. There's a 5x here. And that's a minus 5x there. And then 12 times 3 is 36. Okay, so let's recap on that bit again. We said the opposite of divide 3 is times 3. You've got to be careful. You can't just times it 3 once. There are 2 terms, so you times it twice. Times that by 3, times this by 3, times this by 3. 12 times 3 is 36. 3 times 2 is 6. And then the opposites of one another would cancel out. That's why I've got minus 5x. Yeah? Now here's the last bit. Shh, 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 shh. And please, are you calling him out for a reason or are you bullying? What's the shake your head? I don't know what answer is it?
I'm not bullying him. I'm just asking a question.
Can you ask afterwards? All right, not during my session. Otherwise, it feels like you're bullying. Yeah? All right, next one. So here we go. We've got 6 minus 5x. And now I want you to be careful this step. Samdub. Samdub is you're looking for subtraction addition. Now, what a lot of students see first is this minus. And they think that's minus 5, but it's not. You're not minusing 5. What is actually happening there?
6. Wait, no. That's negative 5.
That's negative 5. And what's between negative 5 and the x?
Times.
Times. This is actually times. That's a times there. This is the addition. And that's where yesterday's mistake was. They see the minus and they go, yep, it's minus 6. That has nothing to do with the 6. That's to do with the 5. The 6 is currently a positive 6. If it was a negative, it would have a negative at the front of it. So you can't just take that negative and just match it with 6 because you want to. They're different. So that's negative 5. What that's saying there is times by negative 5. And this one is adding 6. So when we do Samdub, we get rid of subtraction addition. It's not that minus 5 because it's minus 5 times x. This one, to get rid of it, you're actually doing minus 6. Minus 6 is the opposite of positive 6. See the difference? Okay, so that's where the mistake was coming up from yesterday, that when you're minusing, you're not minusing this 5 because that's a times. It doesn't always have to be a positive number. You can times by positive 3, but you can also times by a negative 3. So in this case here, that's times. Times comes next. This one comes first. Yeah, so that's a positive 6. Positive 6. Opposite of positive 6 is minus 6. Well, whatever you do to one side, do to the other. So if I minus 6 on one side, so over here if I said minus 6, then I need a minus 6 on that side too. 6 take away 6 cancels out to be 0. What's left over? I have negative 5x is equal to 36 take away 6, which is? 30. And remember, what's between the 5 and the x? It's a times, but this is a negative 5.
So negative by negative 5.
Yes, very good. That's the common mistake. So here, students need to know that's a number together. It's divide by negative 5. But whatever you do to one side, you then do to the other. Divide both sides by negative 5. Here we go. Negative 5 divided by negative 5 cancels out. You're left with just x. X is equal to, now be careful, integers back in term 1. 30 divided by negative 5 is?
Negative 6.
negative 6, because positive and a negative gives you an overall negative. And so then 30 divided by 5, which is 6. So your answer is x equals negative 6. Okay, so that last one is a very common mistake, common misconception. Hopefully now you feel a bit more confident with fractions. If you're up to 7C, that's what you'll do. Otherwise, I want you to practice 7B, which is pretty much from that step onwards. SAMDUB onwards. Ones without fractions. Okay? I'm going to stop the video there. This is your session. A reminder,